Welcome to our channel. Imagine the final second when time itself ceases to exist. Imagine looking up at the night sky, seeing the countless stars and the vast, silent darkness between them. Our universe is expanding, carrying those galaxies ever outward, a fact we have known for nearly a century. But a simple, profound question remains: where is it all heading? Where is this grand cosmic voyage ultimately taking us? Scientists have developed several theories for the ultimate fate of everything we know, and each one paints a breathtakingly dramatic final chapter. The concept of the last second of time isn't about a clock ticking down to zero, but about the moment when the very fabric of reality can no longer support change, movement, or events. It is the moment time itself loses all meaning. The most accepted scenario is known as the heat death, a slow, cold, and quiet end. Over trillions of years, the last stars will exhaust their nuclear fuel and flicker out. Galaxies will fade from brilliant spirals into dark, drifting graveyards of stellar corpses. No new stars will be born to replace them. The universe will be populated by the faint, cooling embers of white dwarfs, which will eventually become cold, black dwarfs. In this era, entropy, the measure of disorder, will reach its maximum possible value. Everything will be the same temperature, just a fraction of a degree above absolute zero. With no heat differences, no energy gradients, no fuel for any process, nothing can happen anymore. This is why it's called the slow death of the universe, a final, eternal equilibrium of perfect stillness. A far more violent and dramatic end is theorized in the Big Rip. This scenario hinges on a mysterious force called dark energy. If dark energy becomes dominant and continues to accelerate the universe's expansion, it will eventually overcome all other forces. First, the gravitational bonds holding galaxy clusters together would be torn asunder. Then, individual galaxies would be shredded, their stars flung into the growing void. As the end nears, the expansion force would rip apart solar systems. In the final moments, it would tear planets from their stars. Ultimately, the force would become so powerful it would overcome the forces holding atoms themselves together. Every molecule, every atomic nucleus, would be ripped into a spray of subatomic particles. The entire cosmos would be torn to its most fundamental pieces in a final, catastrophic instant. There is also a poetic, cyclical possibility known as the Big Crunch. In this version, the expansion of the universe eventually slows, halts, and then reverses. The collective gravity of all the matter in the cosmos would finally win its long battle with expansion. Galaxies would begin rushing back toward each other, pulled by an irresistible inward force. The universe would begin to collapse, heating up as it does. The background radiation of space would grow hotter and hotter, eventually boiling away planets and stars. The entire cosmos would collapse into an ultra-hot, ultra-dense state, mirroring its beginning. Some theorists speculate this final cosmic implosion could be so violent and energetic that it might trigger another Big Bang, birthing a brand new universe from the ashes of the old one in an endless cycle of death and rebirth. If the universe avoids a sudden rip or crunch, it will likely enter the black hole era. After all the stars have died, black holes will be the last large structures standing. They will drift through the darkness, slowly consuming the last remnants of dust and gas. But even black holes are not eternal. Through a process called Hawking radiation, they will very slowly evaporate, losing mass over unimaginable timescales. One by one, they will pop out of existence, releasing their final burst of energy. The death of the very last black hole in the cosmos will mark the end of an era, a final farewell to any object with significant gravity or structure. What remains after the last black hole vanishes is a universe filled with a thin, cold soup of subatomic particles and radiation. Electrons and positrons will drift aimlessly, occasionally meeting and annihilating in a final, faint flash of light. The universe will be a sea of incredibly low-energy photons, stretched to wavelengths larger than the observable universe. There will be no atoms, no molecules, no planets, no stars. The cosmos will be an almost perfect vacuum, a near absolute zero emptiness where the very concept of here and there begins to blur. This brings us to the true meaning of the final second. For cosmologists, the last moment of time is not a ticking clock but a state of being. Time is fundamentally linked to change. If nothing can change, time ceases to have purpose or meaning. In this final state, there are no energy gradients left to drive any process. Space itself becomes an empty, static geometry with no events to mark its passage. The universe becomes a silent, eternal void, a fossil of its former self. The last second is the moment this condition is permanently locked in, a moment that, from our perspective, would stretch into forever. There are other, more speculative endings that add a thrilling wow factor to our cosmic pondering. One is vacuum decay, where a bubble of true vacuum forms and expands at the speed of light, rewriting the laws of physics and destroying the universe as we know it. Another involves collisions with other universes in a vast multiverse, a cosmic crash of unimaginable proportions. Or perhaps our universe is part of an eternal cycle of rebirth, with each Big Bang leading to a big crunch and a new beginning. Some even theorize that a hyper-advanced civilization might find a way to survive, engineering a way to escape the end of our universe entirely. So what does this knowledge, of an end trillions upon trillions of years in the future, mean for us today? It reveals the profound nature of our reality, a universe that is dynamic, temporal, and finite in its ability to support complexity and life. It teaches us that time is not a backdrop but an active participant in the cosmic drama, born from the Big Bang and destined to fade with the last usable energy. Scientists study this distant fate not out of morbid curiosity, but because understanding the end reveals the fundamental laws that govern everything from the smallest particle to the largest galaxy. It is a humbling reminder of our fleeting, beautiful moment in the cosmic story, a brief flash of light and consciousness in the vast, dark theater of eternity. Thank you for watching. If you enjoyed this, please like and subscribe for more stories each week.